Hello my dear students, I hope you're all doing well. My name is Benatang Paton and I welcome you all to the channel Classroom where we learn together. So I hope all of you are doing well. Now, my dear students, in today's class, we will be learning about types of chemical reactions. Well, in this chapter, you will be learning about 4 types of chemical reaction. The first one is combination reaction. The second is decomposition reaction. The third is simple displacement reaction. And the fourth is double displacement reaction. So, in today's video, we will be learning about these 4 types of chemical reaction. Now, some of you must have already understood in the class when your teacher taught you. After all, this is an easy topic. But okay, let this serve as a revision for you. And for those who did not understand, okay, quite well, I pray that it will help you. So I'll try my very best to let you understand in the simplest way possible. So we will be learning the definitions of the 4 types of chemical reaction. And then we'll be discussing 1-2 examples, and that's it. Okay, that's how easy this topic is going to be. So just 4 types of chemical reaction. Let's start the class now. So before we proceed, I always remind you all to grab a notebook, a pen or a pencil, because by writing, your brain retains the memory better. Alright, so that is a very, very useful tip for you. So practice the habit of writing down. Don't just listen, because listening, we forget. Okay, I go to the church to listen the preacher. The preaching is very good, but I forget it. Okay, so I forget it. So that's how it is. Okay, I don't write down what the preacher is preaching. I just listen. Okay, and it is so good, but the moment I come out of the church, I forget most of it. That's how it is. Okay, so without writing down, I by myself, from my own experience, I'm telling you that we forget. So take it from me. Okay, take it from me, from your teacher. I'm telling you through my experience that you will also forget. So kindly write it down. All right. So let's start. We will be writing the definition of the first type of chemical reaction, which is yes, combination reaction. So let's discuss number 1, combination reaction. So the definition of combination reaction, the name itself is called combination reaction. Now remember, in every chemical reaction we have 2 substances, 2 important things which you have to know. We have got substances which are called the reactants, which are on one side, and we have the other, which is called the product, which is on the other side. So we have reactants and we have the products. Reactants on one side and products on one side. Without reactants, there cannot be, yes, fill up the blanks. Without reactants, there cannot be, what is the answer? Correct, products. Okay, no reactant, no, yes, product. Understood? So remember, there has to be reactants. Okay, and only when there are reactants, chemical reaction will take place, which will give you the product. Clear? Okay, so combination reaction. In combination reaction, what happens is that 2 or more reactants, they undergo a chemical reaction and they give you a single product. After all, the name is called combination reaction, isn't it? Okay, combination reaction. My right hand, my left hand, they combine and they give you this one. Okay, not a very relevant example, but just to help you understand. Okay, this is an example. Reactant number 1, reactant number 2, they undergo a chemical reaction and they will give you a single product. Okay, just an illustration, but I believe that you will get the idea. Okay, so let's write down the definition of combination reaction. Directly we'll write. We don't need a very lengthy definition. Definition should be short, to the point, and which everybody should understand. You agree with me? Yes. 2 or more reactants combine to give a single product. To give a single product. So this is the definition of combination reaction, which you need to remember. Okay. Now, there is a formula to remember. Okay, what is the formula? So we can always write it like this: A plus B. So here A is one of the reactant and B is the other reactant. So reactant 1, reactant 2 undergoes a chemical reaction, and what will it give you? Well, it is combination reaction, so the product should be a combination of these two. So what are we getting? We are getting AB. Clear? All right. Now let's use an actual example from the textbook. So there are examples given in the textbook, and we are discussing from the textbook only. Okay. So one example is that of magnesium reacting with oxygen. So can you guess the product? Who knows the product? What happens when magnesium reacts with oxygen? When magnesium reacts with oxygen, this is a combination reaction. What do we get? We will definitely be getting a product, but what is the product? It's magnesium oxide. Correct? MgO. Okay. Every chemical reaction needs to be balanced. So let's balance this one. We have, well, 2 oxygen there. Here 2 oxygen, there only 1, so oxygen has to be 2. So in the course of balancing, you write here 2 and you write here 2. So 2 Mg, 2 Mg, 2 oxygen, 2 oxygen. Is this balance? Yes, this is balance. Okay, this is a balanced chemical equation. Now when we study combination reaction, you have to study the 2. Okay, you have to study 2. What do I mean by 2? I mean to say some combination reaction takes place between an element and an element. This is an example of a combination reaction taking place between an element and an element. I mean to say both the reactants are elements only. Okay, the other one is where both the reactants are compounds. Okay, so here this is a combination reaction taking place between an element and an element. Now we have combination reactions which takes place between a compound and a compound. So let's study that. So let's go to the second example. Again, this is taken from the textbook. It is that of calcium oxide reacting with water to give you calcium hydroxide. So we have calcium oxide CaO reacting with water to give you calcium hydroxide. So CaOH2. Excuse me. So calcium oxide reacting water to give you calcium oxide. Okay. Now, so this is a compound. This is a compound. This is another compound. Remember, both are compounds only. Compound and compound. This is calcium oxide. If you want to know the name of the compound, it's calcium oxide. This is water. And this is calcium hydroxide, which is a compound. This is calcium hydroxide. So this example is that of a combination reaction which takes place between a compound and a compound. Okay. Now this reaction is quite important. This reaction is quite important. And in this chemical reaction, there are some observations which are very important also. Now the trend, okay, the trend of question setting by the NBSC is changing. Whether it is a good news for you or a or I don't know how you will react to it, but then the standard of science is increasing, and I take it as a positive step. Now other question papers, I don't know, the concerned teachers will know, but as a science teacher, I see a trend, and the trend is increasing. The trend is that of progressive. So we are progressing now. So after the COVID, well, we all know how the COVID situation went. You know how you passed, isn't it, in the COVID time? So immediately after that, things were lowered a little bit. The standard was lowered to help adjust with that 2 years where everything was affected. But now, okay, this is 2026. Okay, and so some years have passed. Now we are progressing again, and I consider that as a positive step. And I also want to tell you that you should also consider that as a positive thing. Okay, so you should rather like enjoy this, because now the system is upgrading, the system is getting more efficient, the system is getting more challenging. So science as a subject is becoming very competitive, and so you cannot afford to miss it out. So if you like science and if you want to do really well in science, you have to start from class 10. Okay, minimum you have to start from class 10. You should have started from class 8, class 7, but then you are not late. class 10 is the foundation course. You have to master it. Okay, class 9, class 10, very, very important. These two. Okay, class 9 is also very important. So run back to your class 9 and start studying again. Okay, make sure that you know that, because what you learn in class 9, you don't learn in class 10. And then you will go to class 11 and 12 and it becomes very challenging. But even class 10 itself is getting more challenging. So okay, so I want you to like be ready. Okay, I want you to be ready. And if you are interested in science, it's a good sign for you that science is becoming very competitive. Okay, and that is a good sign for you. Okay, so you have to work hard, you have to study more and dedicate more time, and you have to be really studious. Remember, hard work always pays off. Okay, so hard work beats talent if talent is lazy. Remember that. Remember that, very important. So some observations about this chemical reaction, we can discuss those. So observations. Now, if this chemical reaction is performed, now during sports weeks and all that, we go and we buy lime. Okay, we go and we buy lime, which is sold in bags. Okay, they are sold in bags. And then not only that, but during Christmas seasons and during Christmas seasons here in Nagaland, during Christmas seasons, what the government or also the panchayat does is that they whitewash the walls of the road. Okay, the retaining walls along the roadside. The colony people, we do whitewashing. Now during this whitewashing, we don't use expensive paints. Okay, we buy this calcium oxide, which is found in bags, and then what we do is we pour it in a bucket, fill it with water, and okay, we will use a brush and we will start painting the roadside walls. Okay, so this experiment, this chemical reaction, okay, this chemical reaction happens there. Okay, so now, so when this chemical reaction takes place, what happens is that number one observation is that it is a very fast reaction. This is a very fast reaction. What do you mean by very fast reaction? That means the reaction will happen quickly. Okay, so it is a very fast reaction. Next, it is exothermic. This chemical reaction is exothermic. Now, what was exothermic chemical reaction? We have already discussed in the previous videos. So there are two types of chemical reaction, exothermic and endothermic. So exothermic means chemical reactions which releases heat, isn't it? So when this reaction takes place, it releases heat. Okay, remember that it releases a lot of heat. Next, because of the release of heat, what will happen? Now the water boils. Water boils to form steam. With a hissing sound and forms bubbles. Let me just write here. I hope it's visible. So this is what happens. Since it is an exothermic chemical reaction, it releases a lot of heat, so much that the water boils, because there is water present. We have poured water, isn't it? So there's water. So much heat that the water boils and produces steam with a hissing sound. Okay, that hissing sound. Okay, that sound is there, and then it forms bubbles. It forms bubbles. So this will happen right in front of your eye. Okay, if you put this calcium oxide in a bucket filled with water. Okay, so that is why these observations are important. And like I said, we perform this chemical reaction, so we have to know this chemical reaction. Okay, so what am I missing out? Yes, another very important point. Okay, another very important point. You can write it as a note. Okay, that generally combination reactions are exothermic. So generally, okay, so generally combination reactions are exothermic. Remember this. So most of the combination reactions are exothermic. That is a very important point which you have to remember. So we are done with the first type of chemical reaction, which is combination reaction. Now we will go to the second type, which is decomposition reaction. So let's go to the second point. The second one is decomposition reaction. Decomposition reaction. So decomposition reaction is also the opposite of combination reaction. In combination reaction, two or more reactants, let me use this, I have marker with me. So cap and the body of the marker. Okay, so reactant 1, reactant 2, they combine to give you a single product. Now in decomposition reaction, the exact opposite will happen. You have this product, so what will happen? It will decompose. Decompose means it will break, it will split, okay, it will break down, and then it will give you two or more products. So what is decomposition reaction? Decomposition reaction is a type of chemical reaction where a single reactant breaks into two or more products. Clear? Easy? Yes, that was absolutely easy, isn't it? Okay, it was so easy. Okay, so this is easy. So let us write on the definition. a single reactant breaks to give two or more products. This is the definition of decomposition reaction. Okay, now there is a formula, so let's write down the formula first. The formula is AB. Remember, this is our reactant. Okay, AB, it will undergo decomposition reaction, so the reaction will take place, and what will it give you? It will give you two or more products. So AB is a reactant. Okay, this is a compound, and this undergoes decomposition reaction, and it gives you two reactants, A and B. Now this is an element, this is an element. Okay, now let us take an example from your textbook. So there's an example, there are lots of examples given in your textbook. Let us take one, which is that of FeSO4, ferric sulfate or iron sulfate. Okay, FeSO4. This is a compound. This undergoes decomposition reaction to give us ferric oxide, Fe2O3 plus SO2 plus SO3. So this is ferric sulfate, or you can also call it as iron sulfate, because Fe stands for iron. Okay, Fe is the symbol of iron. So iron sulfate, ferric sulfate, same. This is Fe2O3, which is iron oxide or ferric oxide. Okay, so same only. So let's write ferric oxide. So this is a compound. It undergoes decomposition reaction. That means it splits, it breaks to give you ferric oxide, one product. It gives you sulfur dioxide. This is sulfur dioxide, and this is sulfur trioxide. Okay, so sulfur dioxide, sulfur trioxide. I hope you remember. SO2, sulfur dioxide. Okay, sulfur dioxide, and SO3, 3 means tri, sulfur trioxide. So this is what decomposition reaction is. now so remember that decomposition reactions are opposite of which chemical reactions? What did I just say earlier? I have mentioned this, that decomposition reactions are opposites of correct combination reactions. Okay, so remember that. Now now decomposition reaction. Now here, so this compound ferric sulfate, how did it break into this? Okay, this reactant, which is a compound, ferric sulfate. This is a compound, but then here this is the reactant. Is not. This is the reactant. This is the reactant. This is the reactant, and these are the products. All of these are the products. So all of these are the products. So how did this reactant break down to give these products? There must be something, isn't it? There must be something which has helped this reactant to break. It is a big compound. So how did this compound break? How did this compound break? So there is an agent, something worked on this. What is that? Here, this compound broke using heat energy. By itself, so it will not break. If you want to break something, what do you do? If I give you a walnut and I tell you to break it, just by holding it on your hand like this, will the walnut break? Or for example, or just a stone also. I'll give you a stone and I want you to break the stone. So if you place the stone on your hand like this, will the stone break by itself? No. What you have to do? Well, you will throw it on the floor with great force, or you can bring a hammer and then start hitting the stone. What will happen? Because of the impact, because of the energy supplied by you, what will happen? Because of the impact of the hammer, the stone will break, isn't it? So an external force is required. An external force is required. Similarly, here also, we need an external agent to initiate this, to bring about this chemical reaction. Here, we are using heat. So we use heat energy, to break this compound, to break this ferric sulfate into these products. So remember, this reaction is also known as thermolytic decomposition. Why? Because we use heat to break down this reactant. We use heat to break down this reactant. So this decomposition reaction is also known as this is known as thermolytic. Yes, it's not thermolytic decomposition. Let's write it down. The above reaction is also known as thermolytic decomposition or thermolysis, because heat is used to break down FeSO4. Now, but heat is not the only external source or the external factor, or the external thing which can be used. We can also use electricity, and we can also use light. So let's learn about that. What if we use electricity? What if we use electricity instead of heat? Because we can use electricity and then we can decompose. Activity. Which activity is that? But it is there. It is there in your textbook, where electrolysis water. I have just said the name. So if we use electricity to decompose, then to break down, then it is called electrolytic decomposition. And if we use light, because light can also be used to bring about decomposition reaction. If we use light, then it will be called photolytic decomposition. So these things you have to know. So let's write it down. We have already discussed about thermolytic decomposition, which uses heat energy to bring about decomposition reaction. Now, what if we use electricity? If we use electricity, then it will be called as electrolytic decomposition. Okay, so electrolysis. If current is used, if current is used for breaking down, then it is called electrolysis. Remember this? If current is used to bring about decomposition reaction, then it is called electrolysis or electrolytic decomposition. Okay, next one. If light is used, for breaking down, then it is called, what will it be called? It will be called photolytic decomposition. Photolytic decomposition, POSITION. So these are important. You have to know these terms, okay? And also you have to know the different agents which can be used to bring about decomposition reaction. We can use heat, we can use current, and sometimes we can use light. So these are the three agents which can bring about decomposition reaction. So kindly write it down because I'm going to erase it. We will be discussing a little bit about this photolytic decomposition because it is important and it is also there in your textbook. So let me erase this one. And now there are two examples mentioned in your textbook about photolytic decomposition, and both of them are important. Now, example of photolytic decomposition. Photolytic decomposition. So the two examples are here. We have AgCl, which gives you Ag plus Cl2. To balance it, you write here 2 and you write here 2. So 2Ag, 2Ag, 2 chlorine, 2 chlorine. Okay. Another reaction is that of AgBr, giving you Ag plus Br2. To balance it, you write here 2 and then you write here 2, 2Ag, 2Ag, 2Br. Okay, 2Br. Now these are the two examples of photolytic decomposition which is mentioned in your textbook. Now why are they important? They are important, okay, and it has been asked in the exam by the board. Okay, they have been asked. Now why are they important? They are important because they are used in black and white photography. Understood? So this is important. So they are used in black and white photography. Used in black and white photography. Nowadays, our photos are all colored, and these days I don't see people even developing their photos. But once upon a time, okay, people used to buy cameras and then they click photos, and then there is something called a reel, which they give it to the developers. Developers are those which run a photo studio, and they develop the reels. They develop the reel, and then they are given a physical copy of the photo which they took. Okay, nowadays we rarely see that. Okay, so during those times, okay, these were used, and this was especially used in black and white photography. Okay, so before color came black and white photography. So this is important. After black and white photography came color, and now though we are in the cell phone era, so we don't actually develop photos. All our photos are stored inside our phone, and there they are there. Okay, thousands and thousands of photos are there. The day you lose your phone, your images will also be lost. So don't forget to back it up. Okay, always back up your digital files. Remember that. So sometimes do go and like develop some photos and check out the experience. It is very good. Okay, so we are done with this. Now we'll go to the third one, which is simple displacement reaction. I'm going to erase this one now. Let's go to the third one. I hope you all are following. Like I said, it's an easy lesson. So just make sure that you remember the definition properly. Everything is in the definition, okay? Just remember the definition. It is as per the definition, okay? You have to understand, you have to remember the definition. Now we go to the third one, which is called simple displacement reaction. Now this is very, very, very important. Now this is where you have to really okay understand. Now what is, see, simple displacement reaction? What happens here is that in this reaction, an element, okay, a more reactive element displaces a least reactive element from a compound. So let's write down the definition. A more reactive element displaces a less reactive element from a compound. So the definition reads, a more reactive element displaces a less reactive element from a compound. Now, for example, the formula. So a more reactive element displaces a less reactive element from a compound. So in simple displacement reaction, we should have, well, there will be two reactants. One reactant will be an element, the other will be a compound. So for simple illustration, we can write like this: A, which is the element, let A be the element, and let the compound be BC. So what type of reaction will take place? Displacement reaction will take place. And then after the displacement reaction has taken place, what will happen? You will find B here and you will find A there. Now I want to grab your attention here. Remember, my dear students, this is an element. Elements are single and pure, so alone, single. And this is an element, or what? This is a compound. Good, this is a compound. Very good, this is a compound. And please remember this, that the first substance here, this is a compound. That means they are made up of two or more elements. How many elements are there? Two. So the first one, okay, the first one, or you can say the one to the left, which means we are talking about this fellow, okay. Generally, this one is always a metal, okay. Most of the time, this is a metal, and that makes this a non-metal. So remember this, that this is a metal. This is mostly a metal, okay. I'm saying not every time. I'm not saying 100% it will always be a metal. No, I'm saying generally, most of the time, it will be a metal. And from your exam point of view, mostly it will be a metal. They will only give you metal only. And this becomes a non-metal. Okay, this is a non-metal. This is a non-metal. This is a non-metal. Remember that. So remember, it is the metal, okay? It is the metal which gets displaced or which goes into the reaction. This non-metal does not play any role. Okay, they are, what do we call? Non-players. Okay, they don't play. They just remain where they are. It is this metal and this metal which is going to which undergoes the reaction. Okay, the activity takes place between a metal and a metal only. Okay, the clash is between a metal and a metal. Remember that this C is a non-metal, so it does not play any role. It will remain where it is. Now, why I'm telling you is because I want you to bring your attention here now. So I told you that it is between this metal and this metal. Now, the biggest confusion is, see, it's called a displacement reaction. What is a displacement reaction? A displacement reaction is when someone comes and takes your place. So somebody will come and take your place, and where will you go? You will go and take the place which is vacated by the other person. So it's like this: my right hand and my left hand. So my right hand wants to displace my left hand. So my right hand vacates his place, comes to me and tells me to go. So my left hand now moves away. Where will he go? Where will he go? He cannot be here because my right hand wants to stay here. So where will he go? He will have to go and take the place vacated by my right hand earlier. So now this is the new place of my left hand, and this is where my right hand is. How did it start? Where were they before? They were here. My right hand on my right side and my left hand on my left side. But my right hand wants to displace my left hand, so he comes and displaces my left hand. My left hand, where will he go? He cannot be here, so he will go and take the place vacated by my right hand. So this is the new position of my hands now. I hope you got the idea. This type of chemical reactions are called displacement reaction. But here, the most important thing which students need to know here is, how do I know which one will displace whom? Very, very important. Who gets to displace who? Who will displace who? So the most important question is, most important question. What is the most important question here? Who gets to displace who? Who displaces who? Who displaces who? Very, very important. Who will displace who? Who will displace who? There must be a criteria, you know, like how will I know that a particular metal can displace a particular metal? I need to know. So is there a way to know? Because if I don't know, how will I know? How will I know? So there has to be something by which I should be able to know that, oh, this particular metal can displace this particular metal. So is there something available for me, for students to know, by which we can know like that this particular metal can displace this metal, this particular metal cannot displace this metal? The answer is yes. My dear students, the answer is yes, there is. So what is that? That is called the reactivity series. So if you want to know who displaces who, you have to know the reactivity series. Only after you know the reactivity series, you can. So let me give you the reactivity series. You will learn this in chapter 3, metals and non-metals, but it is required here. So we will have to discuss. So the reactivity series, remember the reactivity series. I'm going to give you the reactivity series. Reactivity series. So the reactivity series is a series of 13 elements. Among them, one is a non-metal, which is hydrogen. Now you have to memorize it. Okay, you have to remember the sequence. There's a hack, there's a mnemonic which I have learned from YouTube, and I'm going to share it with you here. So the mnemonic is, okay, that helps you, it will help you remember the sequence. Okay, it will help you remember the sequence. I've already shared this to my students in the class. Now let me also help you here. So we will start like this. So it goes like this. Please stop calling me a zebra. I like her calling me sweet guy. This I learned from YouTube, okay, and I have always been using this. So I will tell it to you, and I already told you also. So it goes like this. Please stop calling me a zebra. I like her calling me sweet guy. So you have to remember this phrase, and you have to write it down like this, okay? Please stop calling me a zebra. I like her calling me sweet guy. If you are a girl, then please stop calling me a zebra. I like him calling me sweet girl. Nah, after all, okay? So I'm a guy, so I'll use this. If you're a girl, then you change it to him, and you can change this to girl, okay? So now remember, P stands for, well, we will be utilizing the first letters only. Okay, the first letters are what is important. So P for potassium. So the metal here is potassium. Then S for sodium. Then C for calcium. CaL, I'm very weak in spellings. CiUm. M for magnesium. A for aluminium. Zebra is zinc. Let me just write down here. And this is iron. Like L for lead. Then H is hydrogen. This is the non-metal. Remember, we have one non-metal in the reactivity series, which is hydrogen. This is copper, I guess. This is copper. This is mercury. And then this is silver. And the last one is gold. So, my dear students, this is how you should remember the reactivity series. But let me tell you, how do we study the reactivity series? Remember, we study like this, okay? We go down like this. The reactivity series is studied like this. We start from here, potassium. And potassium is the most reactive element. So, potassium gets rank 1. The reactivity series starts with potassium. The definition of reactivity series goes like this. The reactivity series is an arrangement of metals in order of their decreasing reactivity. I repeat, the reactivity series, it is an arrangement of metals, okay, in order. What order are they following? In order of their decreasing reactivity, which means as you go down, you will encounter least reactive metals. Okay, so if we start from potassium, that makes potassium the most reactive, followed by sodium, second most reactive, followed by calcium, third most reactive. It goes like this, and you stumble upon gold. Gold is the least reactive metal, okay? I hope you got it. So, you need this to know who will get to displace who. Now, in this example, which I have used, A and B. Now, I have shown you that A displaces B. So, how did I do that? See, we can consider A to be sodium. So let's say A is sodium. If A is sodium, what is the rank of sodium? Second, is it not? Second rank. That it is the second most reactive element. And let's say this is zinc. Let's say B is zinc. So let's say B is zinc. Okay. C, forget about C. Okay, C is a non-metal. There is no non-metal here except hydrogen. So C is not the hydrogen also. So leave it. So we'll pay attention to this one. This is a metal. This is zinc. What is the rank of zinc? First, second, third, fourth, fifth, sixth. It's sixth. This is the rank of zinc, sixth, and this is second. Now you tell me, who is more reactive, A or B? A is sodium, rank number 2. Zinc is rank number 6th. Who is more reactive? Sodium is not. Sodium is more reactive. A is more reactive. So A can displace B. How is A able to displace B? Because A is more reactive than B. So a more reactive element displaces a less reactive element from a compound. B is in a compound state with C. B is in a compound state with C. B and C together they are compound. A is an element. A is more reactive than B. So what will A do? A will go and chase away B and tell, go, I am more reactive, so let me form a bond with C. Okay, so what will happen? B has to go away. Where will B go? B will go to the place vacated by A. So B will be found here now. Previously, A was here, B was there, forming a bond with C. I am A, more reactive than B. So how will I allow B to form a compound? When I am around, when I am more reactive than B, I will not allow B to form a compound with C. How how dare B to form compound with C? So I should be the one. So I will go and displace B. I'll tell B, come out. I'll form a bond with C. Now B has to go, because B will look at me and realize that this is second most reactive element. So he has to go away. So I'll form a bond with C. Where will B go? B will go to the place vacated by me. Understood? This is how displacement reaction works. Okay, so A being more reactive than B, A gets to displace B. B goes away. Where will B go? B will go and take the place vacated by A. That's what has happened here. Remember, B has come here. This place, this is where A was originally, yes, and here B was here, but now you will see A here. Okay, did C move? No, like I said, C is a non-metal. C does not play any role in decomposition reactions. Remember, the non-metals, they don't play any role. They remain where they are. Okay, they remain where they are. It is the metals. The fight is between metals only. So two metals, they fight, and who will, well, what decides what type of, or what decides the outcome? Their outcome, okay, is decided by this reactivity series. So you have to know this reactivity series to know which metal gets to displace which metal. All right. So okay. So now let's take some example. So the formula has been given to you. Let us take an example from the textbook. So the example, what example? Okay, let's use one example. Iron plus CuSO4. Help me, okay? Let's do together. So this is an element, iron. This is copper sulfate. So this is the element we're interested in. This is the non-metal part. This is sulfate, a polyatomic ion. Okay, this is the polyatomic part, the non-metal. They don't play any role here. So the clash, the fight is going to be between copper and iron. Remember, this is simple displacement. Okay, in simple displacement, it is between an element and a compound. In double displacement reaction, it will be between a compound and a compound. But this is simple displacement reaction, so it will be between an element and a compound. Be very clear with that. So the clash is between iron and copper. What will be the outcome? Let's see. Iron, what is the rank of iron? Iron rank is first, second, third, fourth, fifth, 1, 2, 3, 4, 5, 6, 7. 7th rank. So iron rank is 7. Copper rank is here. If iron is 7, 8, 9, 10th. So copper is 10th. You know the outcome, na? So what will happen? Iron is more reactive than copper. So will iron allow copper to react with sulfate? No, no chance. No chance at all. So iron will displace copper. So iron will go and displace copper. So let me show you. So now this one, SO4, is still there. Remember, they don't play any role. They will remain where they are. Now previously it was copper which was here. Now who will come here? Iron will come here. Yes. So iron will come here. Then iron has vacated this place here. This place is empty. Who will come here? Copper will go and occupy the place. I hope you understood. Okay. So this is how simple displacement is. Very simple, isn't it? Very simple. Okay. Very simple. So to understand this, you need to know the reactivity series. Once you understand the reactivity series, it is very easy. Okay. It's very, very easy. Okay. Just like that. Okay. Very easy. I don't know how to snap, but it's easy. Okay, it's easy. So I hope you are done. So now let me erase this one, and then we will discuss the fourth type of chemical reaction, which is double displacement reaction, which is very easy if you have understood simple displacement reaction. Memorize this using this mnemonic. Okay, mnemonic, MNEMONIC. I guess this is the correct spelling. If it is wrong, please forgive me, but this is a mnemonic to remember this. Okay, please stop calling me a zebra. I like her calling me sweet guy. Okay. Oh, I shouldn't have roughed this one. Okay. Now we will be discussing the fourth type of chemical reaction. The fourth type of chemical reaction, which is double displacement reaction. So let's discuss that. Double displacement reaction. If you have understood simple displacement reaction, understanding double displacement reaction will be very easy. There's only one major difference between simple displacement and double displacement reaction. The difference is, in simple displacement, the reaction takes place between an element and a compound. Whereas in double displacement reaction, it is between a compound and a compound. I hope that is clear. Okay. So the definition of double displacement reads like this. It is a type of chemical reaction where a more reactive element from a compound displaces a less reactive element from the other compound. That is the definition of double displacement reaction. Okay, let's write it down. It is a type of chemical reaction in which a more reactive element from a compound displaces a less reactive element from the other compound. So this is the definition of double displacement reaction. Now let's look at the formula. The formula will be AB plus CD undergoes double displacement reaction. Now let us first have a look at this illustration. So I already told you that the metal is the first element. So this is the metal, okay, and this one is the non-metal. So this is the non-metal. They don't play any role in double displacement, nor do they play any role in simple displacement. So these are the non-metal. So what do? They remain in their places. Okay, they remain in their places. So B will be here, then we have a plus, and similarly D will be here. So then displacement will take place between whom and whom? It will take place between metals and the other metal. Okay, it is a clash of the metal. A more reactive metal will displace the less reactive metal. That's how it goes, isn't it? So it will be between A versus C. It's A versus C. So A, okay, and C. It's between A and C. So it's between A versus C. Who will get to displace who? It will be determined by the reactivity series. So remember, so what do we get here? A is more reactive than C. Let's say A ring is, let's say, 3 and C ring, let's say, 6. So A is more reactive than C. So A will displace C. So A will go here and displace C. It will tell C to go away. I'll react with D. So A will come here. And then C gets displaced. Where will C go? Where will C go? C will go and take the place vacated by A. So C will come here. So this is how double displacement reaction works. Okay. This is double displacement reaction where a more reactive element from a compound, A is the more reactive element from this compound, okay, goes and displaces a least reactive element from the other compound. This is the other compound. Alright, and we need to know this. The reactivity series will help you know which will get to displace whom. Okay, so let us take an actual example from the textbook. So example, we can use the textbook example Na2SO4 plus BaCl2. So these are the non-metals. They are not going to participate. They will just remain where they are. So we can start writing them. So SO4 plus Cl2. So now sodium, we can see sodium here. Second, this is second most reactive. Barium is the other metal, and unfortunately barium we don't find it here. But tell you what, barium is the reactivity of barium is lesser than sodium. Sodium is more reactive than barium. Okay, so basically barium occupies the place of C and sodium occupies the place of A. Always A. Okay, A is more reactive. Okay, A is more reactive. May not be, they may even temper it and give you. So my best advice, know this. Okay, know this. One of them, they may shuffle it and give you, they may write BaCl2 first and Na2SO4 second. Don't get confused. Okay, just search for search for the metals here. Okay, I guarantee you one of the metal will be here. Okay, you will find the metals here. You will find at least one. That will give you an idea. So here I don't see barium, but no need for me. Okay, I don't need to worry. Do I see the other metal, sodium? Yes, I see. So sodium is the second most reactive metal. Okay, so I know for sure that sodium will displace barium. Barium reactivity is definitely lesser than sodium. So I know that sodium will displace barium. So sodium will displace barium. So sodium will go and form a bond with chlorine. So you have Na. Okay, we can write Na2 here. Okay, cut this one. Don't need to write this one. You can just write here 2. Okay, 2 here, 2 here. Don't need to write, just write here 2. Okay, this means 2Na2Cl. Okay, same. And then since sodium has gone all the way here, his place is vacated. Who will come here? Well, who was there earlier with chlorine? Ba, isn't it? So Ba will come here and form a bond with sulfate. So this is how double displacement works. So easy, isn't it? It's easy. Okay, it's very easy. You need this knowledge. Very easy. Let's do one more. Ki, potassium iodide, plus lead nitrate, PbNO3 NO3 I want you to try this. Try this. Give me the product. So I will be here. Okay, you can write it first. And NO3. Okay, be careful with such type of compounds. Okay, where there are brackets, you have to be careful. So you know what will happen? It's between this versus this. Potassium I see here. First, the most reactive element. Okay, metal. Lead I see here. So you can see the position of lead. It's way below potassium. Potassium is most reactive. Potassium will displace lead. So lead has to go away. So potassium will form a bond with this one. So we have KNO3. Easy. Where will lead go? Lead will go and take the place vacated by K. So lead will be found here. PBI. 2 is here. So I think everything is alright. PBI2 plus KNO3. So this is how double displacement works. I hope you all understood. Was it easy? It was easy, isn't it? It was very easy. Okay, it was very easy. Like I said, most of you must have understood from the class teacher, from the subject teacher at school. But in case if there was anyone who did not understand well, I hope that I have helped you a little bit also to understand. Okay, so if I have managed to help you a little bit, I'm much happy that I could do that. Okay, that's all I am here for. Okay, and if you have learned so much well from me, then much obliged and much happy that I can be of help to you. So before we conclude the class, I have a question. So let me give you the question, and I want you to participate and comment in the comment box. Okay, your participation will make me happy. So the question which I want to leave you with is, in a chemical reaction between, which question did I use? Between copper and lead, who will get displaced? Who will get displaced? Question mark. So answer, you give it in the comment below there. You kindly comment the answer. Okay, you comment the answer in the comment box. So in a chemical reaction between copper and lead, so these are the two elements, copper and lead, both are metal. I want you to tell me who will get to displace who. Who will get displaced? Okay, so who will get displaced? I'll give you the hint. The hint is a more reactive element gets to displace a least reactive element. So kindly give your answer in the comment box. So thank you so much, my dear students, for tuning in and watching. So we'll end the video here, and we will continue with another topic. Most likely it will be oxidation reduction in the next video. So stay tuned, and I'll be seeing you again. Until then, take good care and God bless you all.